20,245. And over 6 years, yeah, that seems reasonable. Made about $1,000 a year, roughly. All right, any questions? All right, let's go to number 3. This is another money one. Sally invested $11,200 into an account that earns 5% compounded continuously. There's the key word right there. Compounded continuously. If she makes no other deposits or withdrawals, what will her account be in 25 years? So on that one, I have to use the equation, the PERT, the one with the E. So the principal is 11,200, and then that's times E, the P times E to the R, T. The key on that one is remembering that if you see the word compounded continuously, use the equation with E. And again, I'm going to need to bring up my calculator. And that'll be 11,200 times, I hit function, I can get to the E, yep, E, and then RT, 0.05 times 25. And that is a pretty good answer. For 25 years, you would expect it to be quite a bit. 39,090. And again, I'm going to round to the nearest dollar, $2. Questions? All right, I'm going to go on to the next one, if that is okay. If I'm going too fast, just holler. I want to make sure you guys get a chance to get the information down. All right, you are going to have one similar to this on the test. However, on the test, I don't give you the graph. You'll have to either graph it by hand, make a T-table, which I don't suggest. What I suggest is you just open a separate window of Desmos, type the equation in, okay? But sketch graph of f of x equals 3 to the x, which that makes sense. It's a growth. My y-intercept is going to be 1. My domain is going to be all real numbers. Because I have negative x values, I have 0, and I have positive x values. My range, though, which are my y values, I'm only going to get an output that's positive. So my range is greater than 0. Don't put an equal sign with it. It'll be wrong. The y-intercept is 1, or you can give it as an ordered pair. And the asymptote, I can't write on that graph. The asymptote is a horizontal line, which would be y equals 0. This is some past knowledge that we've talked about with range and domain before. At the very beginning, I think our first lesson, we talked about the growth and decay. So don't overthink this problem if you see one similar to it.
I kind of forgot about the asymptote of the graph. How do we do that?
Okay, well, you have to just look on the graph on that one. That's a good question. But like here, my range is y is greater than 0. So it's getting really close to that value of 0. Y is getting really close to the 0, which is the x-axis. So remember, y equal is always a horizontal line. So right there in red is my asymptote. And then the graph gets really close to that, but it'll never touch that asymptote. So you're really getting that asymptote just off of that graph, or looking at what that output is and realizing that nothing is going to go underneath it. It's going to get really close. Like you might, if you made a t-table, you might get like 0.001 for your y value, but it's never going to reach 0. Aishi, does that answer your question?
Yes, I got it.
Okay. Thanks for asking. All right. Go to screen number 5. We're going to do this one without a calculator. The trick on this one is knowing that 0.25 is 1/4. And 1/4 is 4 to the negative 1. So if I took log base 4 of 4 to the negative 1 equals x. Now that log base 4 and the 4 kind of cancel each other out. You can kind of think of it that way. Or I can go ahead and write in an exponential. 4 to the x equals 4 to the negative 1. X is going to be negative 1. I could have also done that with a change of base, where I just did common log 0.25 over log 4. You will have one similar to this on your test. All right. 6. Tell you what, you guys expand that first, and let's see how you guys do. I'm going to bring up the teacher screen so on my other computer, and I will be looking at it. I will tell you right now, there is a trick on this. Probably send a couple of you some messages. All right, you guys are falling for the trick. I'm gonna wait for a couple more people. I see a couple people figuring out the trick. All right, I'm gonna bring up Layla's. Going to be 2 plus 4 log A plus log B. And let's take a second and talk about why. So when I separate that, I know, hey, I've got 4 factors. I have 100, A, and B. And I'm going to separate those with a plus sign. So I'm going to have log 100 plus log, and you might do a couple of these steps in your head, a to the 4th plus log b. Well, log, this is common log. Log of 100 is 2. That one can be simplified. I can move that exponent out front. 4 log A plus log B. And I was 100% trying to trick you on that first term. So be careful of that. I'll give you guys a second to fix any work that you want to. While you fix that, I'm going to have a sip of coffee. All right. Tell you what, when you're ready, go on to the next screen. We get one that's fun to solve. Okay, on this one, the trick is to get everything in the same base. So you have to remember that the square root of 3 is 3 to the 1/2. 1 over 9 is 1 over 3 squared, which is really 3 to the negative 2. That right there is the trick to the problem. So we're going to have 3 to the x times 3 to the 1/2 equals 3 to the negative 2. So now we've got all of the same base. If you are multiplying and you have the same base, you add your exponents. So 3 to the x plus 1/2 equals 3 to the negative 2. Well, you've got one base. your bases are the same on both sides, so you can set them equal, or the exponents. Sorry, I said that awkwardly. Set your exponents equal to each other since your bases are the same. So x plus 1/2 equals -2. Subtract 1/2 from both sides, and you get x equals -2 and 1/2. Or if you want to get fancy, -5/4. Oops, that does not look like a 4. Why did I put a 4 there? Oh my goodness. -5/2. Maybe I need to drink more coffee. And I still hear a lot of keyboards going, so I'm going to give it a second. Hey, Layla, I saw on your screen that you're doing the caret. If you type in the little square root sign, it'll bring up math type, and it'll automatically then give you an exponent. Kendall, looks like you're doing the same thing. So if you want to get math type, just hit that little square root right there. Jacob, same thing. I'm going to go ahead and open up 8, and I'll let you guys try that one on your own. I'm going to type this one. I purposely put common logs so we didn't have to do subscripts. Try and give some comments here. Looks like people are getting this one. Tell you what, looking at my Chromebook, it's hard to see that typing. I'm going to also write it over here. Should be log x minus log 5. And you can put parentheses around those if you want to. It's not necessary. Minus 4 log z And as I said, a lot of people got that one right. So I am very happy. Everybody's favorite, word problems. I give people a chance to figure or finish up screen 8. Go over to screen 9, read the problem to yourself. We'll do it in a second. Or if you're feeling brave, try it right now. All right. A study in Florida found that number of fish Y. So right here is the number of fish. In a pool or lake can be modeled by the following function. And they give us a nice formula. Where A is the area in square meters of the pool or lake. So estimate the number of species in a lake with an area of 70,000 square meters, round to the nearest whole number. Okay, this problem is designed to look hard with that formula. It's not hard. They're telling you what A equals. A is your area. It equals 70,000 square meters. So you're just going to plug that in, and it's going to become calculator work. I don't know if I have enough room. I'll try. 30.6 minus 20.5 times 70,000. Oops, I forgot my log. Don't forget your log. Log of 70,000. I'm going to have to go into the next line. Plus 3.8 log 70,000 squared. Now I just made numbers up, so I'm not sure what the number on this is supposed to be. So let's go ahead and bring up our calculator. So 30.6 minus 20.5 log 70,000 plus 3.8 log 70,000 squared. And I got 20.48. Well, it says round to the nearest whole number, so 20. And then I kind of asked myself, does that seem like a reasonable answer? The number of fish species. Well, I'm not a fisherman, but 20 does seem reasonable. If I'd gotten a negative answer, I would have thought I had done something wrong. If I'd gotten 1,000, I would have thought I'd done something wrong. 20, yeah, it seems reasonable. So something like that, don't overthink it. Okay? Any questions? Tell you what, try number 10 on your own. And I'm going to look at the teacher screen and see how you guys do. I'll try and give some commentary as you are doing it.
Miss Wheeler, can you turn back to the last sum? I couldn't.
Yeah, right there.
Yeah.
Sure thing.
Oh, okay, thank you.
No problem. Sometimes when they give us something like 500,000, I'll go, well, I know I'm dealing with um, a big number there. I'm just going to put 500 and know that that's 500,000 because I'm kind of a lazy writer on that one. All right. One mistake I've seen a couple people make is your percentage. Move that 2 decimals, not just one. So it's 0.0175. All right, I'm seeing some good answers. On this one, don't get confused. You can use the compound interest formula, but your n is 1, so you would be dividing that by 1, which doesn't affect it. So I'm not even going to write that down. And your t is 5. And if you wanted to use n equals 1, it would be 5 times 1, which is just going to be 5. So I don't need to write that. So then it just becomes calculator work. 500, and again, that's in thousands, times 1 plus 0.0175 to the 5. That's 545, and again, thousands, 308. So their population's going up, not a whole lot. I'll go ahead and open up the next screen. When I see the majority of the people on there, I'll go to it. We get to solve one. What I noticed right away on screen number 11, that plus sign, I'm going to combine those guys. So I'm going to have log 5x times x minus 10 equals 3. Well, now I'm going to write it in exponential form. This is common log, so the base is 10. So 10 to the 3 equals 5x times x minus 10. And now it just becomes kind of an algebra problem. Let's distribute and simplify some things. 1,000 equals 5x squared minus 50x. Looks like I have a GCF of 5. So I'm going to just divide every term by 5 and get 200 equals x squared minus 10x. Well, one thing I remember from first semester is if I'm solving, it needs to be set equal to 0. So x squared minus 10x minus 200. Oops, forgot my x. Equals 0. Factor that. X minus 20. X plus 10. Two numbers that multiply to 200 or negative 200. Add to negative 10. When I solve that, I get x equals 20 and x equals negative 10. The trick on this one is remembering something that I'd said early on. You can't take a log of a negative number. So if I plug negative 10 in there, if you in your calculator, you try to take the log of negative 50, you're going to get undefined. Okay? That's because our output has to be positive. That range has to be positive, okay? So we're going to cross that one off. Our answer is just x equals 20. I kind of like that problem. When you're ready to go on to the next screen, just click on it. On the next screen, there's one piece of useless information that they give you that you kind of have to sort through. So, in a secret lab, 70 cells are present at the beginning of an experiment. So that means your ace of naught is 70. During the first 3 hours, the number of cells increased by 90% each hour. That 3 hours, it doesn't really matter because they're giving you a rate per hour. So 90% each hour. We want to write an exponential number or an exponential model giving the number of cells y present t hours after starting the experiment and estimate the time when the number of cells is 600. Okay? So our beginning is 70. Our R and its growth is going to be 0.9 for 90%. And that's just T. So Y equals, I'm going to do that in math type. Y equals 70 times 1.9 to the T. There's your equation. Then the second part, estimate the time when the number of cells is 600. So 600 equals 70 times 1.9 T. Divide both sides by 70. So 1.9 T, that should look more like an exponent. So 1.9 to the T equals 60 over 70. 60 over 7. I just simplified by crossing off one of those zeros. I'm going to write that in log form. So log base 1.9 of 60 over 7 equals T. This is a good one to use your change of base on. I'm going to change the color so you can see. So that would just be the log of 60 over 7 divided by the log of 1.9. I'm going to use my calculator on that. So log 60 divided by 7 divided by log 1.9. And I get a pretty reasonable answer there, 3.347. So I'm going to say 3.35 hours until the number of cells is 600. I like that problem. Give people a chance to finish that up before I go to the next one. I did open the next one up if you want to try and work a little ahead on that one. I think this one right here, there's a lot going on, but you are going to get one very similar to this. Tell you what, I'm not 100% sure if I made the calculator available on the test that you can pull it up like this. If not, right after this, I will change that so that you can. Because I think it's nice to be able to pull up the scientific calculator. If you have Desmos open. All right. This one, I would just use change of base. Log 200. Log 8. You're not going to be able to write those in the same base because 200, you can't write that with a 2. So you really are kind of stuck using change of base. That's just calculator work. Log 200 divided by log 8. And I got 2.548 if I round. And I think I give a little bit of leeway, maybe 1/100 of a point on typing it in Canvas. All right, next one. We could do this two ways. You could do this one with change of base, or I'd notice right away I can get those in the same, I can rewrite those with the same base. So I think I'm going to do it without a calculator. I think that's more fun. Log base 64 of 8 equals x. I'm going to rewrite that in exponential form. 64, the x equals 8. And what I noticed right away was 64 is 8 times 8, or 8 squared. Eight, you can rewrite that as 8 to the 1. So 2x equals 1, or x equals 1/2. So that's one way to do it without the calculator. And if you see that right away, it's an easy problem. If you did not see it right away, you could have just done log 8 divided by log 64 and gotten the same answer. Log 8 divided by log 64, 1/2, 0.5. Whatever you're comfortable with. All right. Try the next one on your own. I want to see where you guys are at. That's screen number 15. I see people on the right track, so this is good. Yeah, a lot of you are rewriting that in log form, which is perfect. Log base 9 of 15 equals x. And then you're using your change of base. Becomes just calculator work. Yeah, and if you just put 1.23, that's fine. You what, if I see a bunch of people on screen 16, I'll go ahead and move over there. Otherwise, I'll leave this up for just a second. And as I said, I'm recording this. I'll try and post this probably this period. Oh, I like this one. There's going to be one like this, and we had some like this on our homework, where they give you the formula y equals ab to the x. And if that first number is a 0, that second number is your a. And you can go through and figure that out the longer way, but it's easier just to remember that's the a, because that's your x and your y. You'd have 2 equals a times b to the 0. Well, anything to the 0 power is 1, so a has to be 2. But whoops, what did I put? 2 equals 2. But I always just remember, if your first number is 0, your second number is a. Well, now we need to know b, so you use your other ordered pair, which was 2, 8. And again, that's my x and y, but I also know a. So 8 equals 2 times b to the 2. Divide both sides by 2. Take the square root. B is 2. So then we can write our equation of y equals a times b to the x. Now, technically, we could simplify that a little bit further because they have the same base, but I'm going to leave it in this form. Now you will have one of those on your test. And again, those of you who are typing, mess around with that math type. It might make things a little bit easier for you, but it's your call. Do you guys prefer the choice of typing or versus writing? I'm going to try and put that in from now on, that you can either type or write. All right, we have one more question. Oh, and it's a super easy question. I'll let you guys try that one on your own, and then we'll talk about it. Is that screen number 17? Hey, Molly, see if you can simplify 100 to the 1/2. And I don't know if I agree 100% how that's written. Yeah, because first thing I would do, is take that exponent. And I see a couple people have done this. And you get 1/2. Actually, that was not a good number to choose because I could see just simplifying this one. And make that to the 1/2. What is 100 to the 1/2? One 100 to the 1/2 is the square root of 100, which is 10. So that's going to be log x cubed over 10. Okay? And I'm going to write that a little bit bigger down here. 100 to the 1/2 is the same as the square root of 100, which is 10. And they're being separated with a minus sign. What you want to be careful about is don't do this. Don't put log x cubed all over 10. Okay? You're taking the log of x cubed over 10 like that. Okay? And then when I look at that, log, I don't know that I chose good numbers on that one. I should have chosen a different number because some people might have said, well, that's log of 10, which is 1. So if you simplified it that way, I understand that as well. But I would put this as my final answer. And because of our discussion about the Avengers last week, you can be confused Hulk, a little lost, okay, I got it, or smart Hulk. And I think they should have also put 3 pictures in here of have old style Hulk from the 70s. It was a great show. You were supposed to go home and watch it. You watched what?
I watched it instead.
I watched that a few weeks ago.
I'm about to
It's a lot of movies. A lot of movies. All right, well, I'm going to stop recording. Does anybody have any questions?